Symbols are simplified representations of actual devices. They are used to represent electrical components in electrical drawings and diagrams. A device's symbol includes a distinctive shape that represents the device and an indication of where its terminals are connected when used in a circuit. A terminal is a place on a device where a connection can be made to either a conductor or another component. Terminals may be in the form of a screw post, a protruding wire that has been connected to the device by the manufacturer, or some other type. Most of the components we will study in the DC portion of this course have 2 terminals. Later, we will introduce devices with 3 or even more terminals. Here are some very common electrical devices and their symbols. A lamp is a common electrical load. Recall from the last section that a load is a device that converts electrical energy into some other form of energy. A lamp is a load that converts electrical energy into light energy. A cell is one type of a DC power source. Strictly speaking, the symbol for a single cell is the one shown here, with one long and one short line. However, it is common practice to represent any battery, regardless of the number of cells it contains, with only 2 cells drawn. As you know, batteries are marked with a positive terminal and a negative terminal, and it is very important to keep track of which is which. On the battery symbol, the positive terminal is indicated by the longer line and the negative terminal by the shorter line. The plus and minus signs are not usually drawn on the circuit, so you must learn to recognize which is which by looking at the symbol. A switch is a control device. If the switch is open, as shown here, no current can flow. If the switch is closed, the circuit is complete and current can flow from the power source to the load and back to the opposite side of the power source. A fuse is a component that protects other components if too much current is flowing, probably due to a malfunction in the circuit or an attempt to connect too many loads. A fuse is designed to melt, creating an open circuit, and this stops the flow of current. A resistor is a type of load that usually is used to limit the amount of current flowing in a circuit. Resistors convert electrical energy into heat energy. Wires and other conductors are represented with lines. There is no way to tell from the way the lines are drawn whether the conductor is insulated or not. Here are some additional symbols that are commonly used to represent various types of power sources. On the far left is a symbol for an AC voltage source. We will postpone consideration of AC circuits until later in the course. Next is the most common symbol used to represent a battery as typically drawn. Remember that the side of the symbol with the longer line, in this case at the top, is the positive terminal, and the side with the shorter line represents the negative terminal. To the right of the battery symbol is a symbol representing a generic DC voltage source. It could be a battery, or it could be a DC source derived electronically from an AC power source, such as a portable AC power supply plugged into an outlet and used to provide power to a laptop computer or other electronic device. Last, on the far right, is the symbol for a DC current source. Physical devices that act as current sources are derived from voltage sources with some additional components. Later we will see that when analyzing circuit behavior, it is sometimes convenient to treat one or more energy sources as if they were current sources instead of voltage sources.